Okay guys, we are doing series in Precalculus. So let's do them. So we're in lesson 2. So summation of notation, right? So it is just how you note the series and for summing them up, right? So if you are doing series, you're summing up your sequence. So for example, you have 1, 3, 6, 12. So this is a geometric series, and then so you want to add it up, add them all up actually. So that will be 1 plus 3 plus 6 plus 12 plus 24 all the way down, right? Times 2. Okay, so how do you note that? How do you make a notation? So this is how you do it. You write a symbol that kind of like a Z. Okay, kind of like this. So we have this E symbol, and then underneath it is I equals to something, right? It can start from, normally it will start from 0, and it can start from 1, it can start from any place you want, and above it is the number that you end up with. What's the last number, right? That's the last number of the sequence or the series. And beside it, you have your function. So just like a function, you're gonna plug in the 1 inside your function, right? If you have an f of x, that will symbolize as your x in the summation, right? So this is a summation, and it's kind of like a special function, how you write a f of x for summation, and that's a E symbol, and right above it is the number you end up with. That's your n, right? And underneath it is where you start. It's your A1, right? Okay, so beside it, it's gonna be your function. So you put your 1 into it, and how about 2? It's a sequence, right? Oh, it's a series, right? So you start from 1 and 2 and try them all out, right? You try them all out. So how about a 1 that sum up to 100? 1, 2, 3, 4, 5, right? If you have a 2 in front of it or behind it times 2, then what you're gonna end up with? You're gonna end up with a series that has 2, 4, right? Because you plug in the 2, you plug in the 1, that will be your 2, and you plug in your 2, that will be your 4. So 2, 4, 6, right? You plug in your 3, then it's gonna be a 3. It's gonna be a 6. So all the way down, 2, 4, 6, all the way down, right? And you sum them up. That will be a arithmetic series, right? It's not a geometric, because apparently 2, 4, 6 is adding 2 in between, right? Okay, let's see other type of summation. Here you have a summation that starts with the 0, and anything that has a 0 times anything, in this instance you have a pi in front of it. So you're gonna get 0 times 0 is 0, and times pi is gonna be 0 for the first term, right? What about the next term? You start from I, you're gonna go all the way to 50, right? So 0, 1, 2, 3, 4, 5, all the way to 50, right? So you're gonna plug in the 1 for the next term, right? The next term will be 1 for I. So 1 squared times pi is gonna be pi, right? Okay, all the way down. So that's the theory. Well, that's the formula and our notation for summation, right? Okay. So we're gonna jump into the next video. So here you have a geometric sequence. So what does geometric sequence do? They have an A, well we say A1, the first term, right? And then you times in R for the next term. And for the next term you times R again, right? Your rate. Alright, so the rate will be your common rate or common ratio. Okay, so what about this one? This is like 5 over 7, 5 over 7. You times the 1 over 7 every time you jump a term, right? So when you add them together, you know your geometric series formula, how you sum them up. Then you're gonna use what? 1 minus R, right? A1 times 1 minus Rn, right? To the power of n, and the parenthesis, and over 1 minus R, right? That's your summation. Okay, so how about this one right here? That's times 2, okay? And this one is a little bit tricky, but I'm sure you're gonna figure it out. This is 1, right? But what is our rate? What is our rate here? Our next term is gonna be minus 3. So it times minus 3, right? And that's tested out for the next term as well. And we times the minus 3 again, that we will end up with 9, so that's correct. And times 3 and minus 3 again, we will end up with negative 27. So this tests out as the rate is minus 3, and our first term is 1. Alright? Okay, so that's our geometric series when we add them up, right? We were talking about the sequence. Now we just add them up, we end up with series. Alright? Okay, so when you try to separate this into this kind of format here, we have our first term, and we have our first term times our rate, right? Our 1 times the negative 3. So that's how you end up with this series. Okay? So let's try to apply the summation, right, notation to this. So we have a zigzag E, and underneath it is going to be the one that you start, which is k equals to 0, right? K equals to 0 is saying it should be n, because this one is using n, so the video in here should be using n equals to 0, right? And then we have an A, and there's an R, right? Okay, AR, right? And we have an N, and here you can either choose either A, N or K, doesn't matter. Okay, what's important is that you apply the sequence to the point where you want to end up to, right? Where you want to sum up to, right? For instance, it's going to be 30, then it's going to be 0, 1, 2, 3, all the way to 30, right? So 0, you applied it to here. What's anything power to 0? The power of anything that is 0 is, it's going to be 0, and it's going to be 1, right? R to the power of 0 is 1. So A times 1 is going to be just our first term, so which is A, or A1. And then we all the way down, and then we can see that we have this 30 right here, right? Or we can say 29. If the question is asking you about the 30th term, we want to add up to 30th term, you're gonna think of yourself that the first term doesn't count. The first term we didn't apply nths because we start from 0, right? So the 30th term, the first term will be 0. Our last term will be times by r to the 29th, right? We start by timing r for our second term, right? Not the first term. So our first term will be 0 with our r, and we start to apply the r for our next term. Okay. All right. So that's worked out some examples. Okay. So we have the first example here. So this is a summation notation here, and our first term, like I said before, is 0. So the question is asking you for the 100th term, right? The 100th term. But what is our first term? Our first term should be 2, right? Because 3 to the power of 0 is gonna be 1. So 1 times 2 is just 2. And what about our next term? Term 2 will be 6. Term 3 will be what? 3 times 3 is 9, will be 18. So we are timing 3 for each of our term in this series. Okay? So it says all the way to 99, but supposedly it's the what? It's the n plus 1 term. It's a plus 1 term, right? So 99 plus 1 is going to be 100. So we can apply the series formula right here, right? So we add them up together. It's going to be, first term is 2 and 1 minus r, which is 3 to the power of 100, because our n is 100. And our denominator will be what? 1 minus r, which is 1 minus 3. And you plug that into your calculator, you're going to end up with what? End up with this number here, 3 to the power of 100 minus 1, right? Okay. So for our next
0.47 and
this is our question. A new social media site has increased 47% each month for the past year. The number of users on January 1st of last year was 50,000. So our first term is 50,000, okay? That's where we start. But watch out what the question is asking you. Which expression below gives the total number of new users? It just wants the new users that were added, okay? Not what you end up with and not what you started with, okay? So it just wants the numbers that were added, okay? So we have 50,000 as our start, so that's not what we are adding. What we are adding is what? We are adding 50,000 times 47, right? 47%, because we have an increase of 47%, and it's not asking you what you expanded into, it's asking you the amount you added or the amount you expanded. So that will be 50k, because we're actually using the number 50 because it's in thousands. Okay, so 50 times 47%, that's our first increase. How about our next increase? Our next increase will be our next term, right? Our next term is what? Our next term will be 50,000, or 50 in this case, and then times by what? 1.47. That's our next term. That's what we expanded into, right? For our second term. So our second term will be 50 times 1.47. Okay? And then we're gonna say, okay, So 1.47, that's our second term, but what we have added for our second term or second month, because you see here, added through month end of the past year. So this is our first month, what we added for the first month, what we added for the second month, all the way to the 12th month, right? So what we have added for the second month is 50,000 times 1.47 times 47%, right? So 50 times 1.47 times 47%, okay? So you see here the second term, we applied the rate. So our rate is 1.47, but we only apply for the second term, not the first term. So if we get to the number 12, that will be what? That has to be in -1, right? That has to be in -1. So we have a 1.47 to the power of 1, right, for the second term. And for the 12th term, we have 50 times 1.47 to the power of 12, right? And times 47%, okay? So we add them all together. Then what do we get? So it's gonna be 50. We get the 50 out, right? We get the 50 out. Okay, let's fast forward. You see here, this is what we wanted, okay? So 1.47 times 0.47 is what we added, right? So we started to see the pattern here. We just want the 12th term will be 11, right? So 11 is our last term, but we take the 47% out of our equation. 47% out of our equation. So you started to see it seems like our second choice here, our second selection here is probably our answer, because we took the 50 out and we took the 0.47 out. So we left with what? We left with our rate inside of the original equation, original series, right? Okay, so we're actually selecting this, right? We're actually selecting this because we took them out. Okay, so all the word problems, especially in pre-calculus level, it's a harder algebra 2, right? So it's asking you to find the pattern first for the word problems, okay? For all the word problems for series, you're gonna see try to push this pattern first. Try to find your A1 and R and try to be very clear on that. Okay, so we start to see our next. We'll start with our next word problem. It's the same thing, and we're trying to push the what? The pattern, okay, or the series actually. Okay, so we have a $200,000 loan. So we have a $200,000 loan, and we have 30 years, but we pay monthly, so we have a 360 payment or months. We pay every month, so 30 years, but that's actually 360 months, or we pay 360 times, right? And then we have a 6% interest. We have a 6% interest, and that will translate to what? A 0.5% monthly interest, okay? 0.5% monthly interest. And what is 0.5%? That will be 0.005, right? Okay, so 0.005, okay? But when you apply the interest, you apply to the original loan, right? That's how the bank makes money. So 200K times 1 point, because you have to expand it. So expanded, you have to apply the 1 itself to it to expand, right? If you have nothing to expand to, and you apply the rate, that will just shrink it, right? Okay, so 1.005, like it's entailed in here, we're trying to derive this question to this answer, $1,200 per month. Our principal, not our principal, that our monthly payment, right? Our coupon payment, for those of you who are keen to learn the financial side of it. Okay, so this is our monthly payment of $1,200. We try to, with this information, and we try to get this number here. Okay, so 200,000 times 1.005, and you pay monthly, so you pay the $1,200 later, and then that's your what? That's your first month's payment. But we still have 359 months to go, right? So you apply the rate again for your leftover, which is your total payment, total loan times the interest, which is your new amount of loan, and minus the principal, your monthly payment, and apply the interest rate again. So, and then you minus your next month's payment, which is again $1,200. But we don't know this yet. So we will substitute this with P, okay? So 200K times, we don't want to use K, okay? We will use the regular number, $200,000 times 1.005 minus P, because we don't know the payment yet. We don't know the amount of monthly payment yet. And then times what? 1.005 minus the P, and then times it again all the way down until you paid it off, right? To 0 here. Okay, so you try to derive the, so now you don't see the 1,200 in this case. Okay, so now what if I say you just pay it once and you paid it off? You just want to pay it off the next month. So that your n will be what? The number will just be one term, right? So n equals to 1. When n equals to 1, when n equals to 1 here, that equals to what? 200,000 times 1.005 minus P equals to 0, because you paid it off in your first term. Okay? How about m equals 2? That will equals to what? That will become $200,000 times 1.005 minus P, and then applies the 1.005 again. And then what? Minus equals to 0, right? Because you paid off twice. Alright? Because this gets a little bit confusing, because a lot of algebraic numbers here can be substituted with the real number. So what we have on the paper is 200,000 times 1.005 minus P equals to, I move the whole 1.005 to the other side. So that equals to P divided by 1.005. Okay? So the first term is, when you move the P around, you will get what? 200,000, and divided by 1.005 on both sides, you'll get what? 200,000 equals to P divided by 1.005. Okay? So that will be your first, we'll leave it as is. Okay? We'll leave it at that. Okay? And then our second n equals to 2 here. That will be 200 equals to P divided by p divided by 1.005 and plus p divided by 1.005 to the power of 2. And you can see your loan, which is 200,000. Your loan equals to 200,000. So you started to see a pattern, right? So your first term will be, back to our original question. Our original question is asking you for 360 months or 360 payments. So that's our original, what the question is asking you. So our n is 360, right? So you can apply your what? You can apply your, let me just pull out a board because it's easier this way. Okay, so your rate, your A1 is what? Your A1, as you can see here, is this term right here, p divided by 1 plus I, which is 1.005. Okay, that's your first term. $1.005. How about your rate? Your rate will be applying what? 1 over 1.005. That's it, right? 1 over 1.005. And what about our n? Our n is 360, right? So altogether, you can apply your formula for the summation of the series, right? So p divided by 1.005, that's your first term, and 1 minus your rate, which is 1 over 1.005, and then that will be 300 to the power of 360, right? And then over what? Over 1 minus your rate, which is 1 over 1.005. Okay? And that will equal to what? Because we leave our 200,000, our loan, on the other side. Of course, your payments, if you sum it up, has to be your loan amount, right? Your original loan amount. You have to pay it off, plus your interest. So you have to, I'm not sure why is it doing that. Okay, let's do it again. 200,000. Now equals to 200,000. And then solve for what? This equation here, you solve for p, right? So your p equals to 1200. Okay, you plug it into your calculator and you end up with 1200. Okay, that's basically what this is entailing. Okay, what this question is entailing. Okay, so good luck on your test and have a nice day. Thank you for watching.